Hi students, this is part 2 of Organic Chemistry Lesson 1. Now let's continue. Mass number. This refers to the number of protons and neutrons in the nucleus. For example, hydrogen can have a mass of 3. Since it has 1 proton, it must have 2 neutrons, okay? And how are you going to get the number of neutrons? Just use this formula. Mass number minus atomic number. You just have to take note that the atomic number indicates the number of proton. Therefore, the number of neutrons, which is 3 for the mass number given in our example, minus 1 for the atomic number, since the atomic number of hydrogen is 1. So 3 minus 1, the number of protons is 2. Okay? So you just have to use this formula in getting or for computing the number of neutrons, mass number minus atomic number. Why use this formula? Because mass number is equal to the number of proton and neutron in the nucleus, therefore a combination of proton and neutron. So if you're only asked to get the number of protons in a certain atom, then you just have to subtract the atomic number from the total mass number. So the mass number is 3, and so minus atomic number, so 3 minus 1. Okay, so just take note that atomic number indicates the number of protons. So mass number minus atomic number, then you will be able to get the number of neutrons. Now, let's have some examples in determining the number of protons, neutrons, and electrons. Li, or lithium, has a mass number of 7 and an atomic number of 3. Okay? So, since it has an atomic number of 3, it is understood that the number of protons is also 3, same as the atomic number. Now, in getting the neutrons, just use the formula we have mentioned earlier, mass number minus atomic number. So, in this case, if you're going to refer to your periodic table of elements, the mass number of Li, or lithium, is 7. So 7 minus the atomic number 3 is equal to 4. Therefore, the neutrons of lithium is 4. Now we have Ne, or neon, has a mass number of 20 and an atomic number of 10. Okay, since it has an atomic number of 10, it is understood that the protons, or the number of protons, is also 10. So using the same formula, mass number minus atomic number. So our mass number here is 20 and we have atomic number of 10. So 20 minus 10 is equal to 10. Therefore, neon has 10 neutrons. Okay, let's proceed to this part. The electrons are equal to the number of protons. Okay, so just remember the atomic number indicates the number of protons, while the electrons are equal to the number of protons. Okay? For example, He, or helium, has a mass number of 4 and an atomic number of 2. Okay? Look at that one. It has a mass number of 4 and an atomic number of 2. So helium has how many protons? 2. And how many neutrons? 2. How many electrons? 2. Okay? Don't forget that one. Electrons are equal to the number of protons. And how are you going to compute for the neutrons again? So follow this formula. Mass number minus atomic number. So in this case, our mass number is 4, atomic number of 2. So 4 minus 2 is equal to 2. So helium has 2 neutrons. Okay, I hope you get that one. Now, let's proceed to chlorine. Chlorine has a mass number of 35. How are you going to get the mass number? You just need to refer to your periodic table. So you must have your own periodic table in handy with you. And then, the atomic number of chlorine is 17. Okay? So, therefore, there are 17 protons and 17 electrons, since electrons is equal to the number of protons. Now, how are you going to compute with the number of neutrons? So mass number minus atomic number. So 35 minus 17 is equal to 18. Now, we have K, or potassium. It has a mass number of 39 and an atomic number of 19. Okay, since the atomic number is 19, therefore the potassium has 19 protons and 19 electrons. Okay, and how are you going to compute for the number of protons? Again, use the formula mass number minus atomic number. So 39 minus 19 is equal to 20. It's easy, right? Okay, determining the number of subatomic particles of ions. In these examples, we're just computing for the protons, neutrons, and electrons of a neutral atom. Now, if an atom is not neutral, or if they are charged atoms, then we refer them as ions. Okay? So, it's still the same in getting the atomic number. It is equal to the number of protons. For the mass number, or mass number is also called nucleons, mass number is number of protons plus neutrons. The number of electrons is equal to the number of protons. However, this only applies to neutral atoms. Okay, I just placed here. But just remember that when the number of electrons is only equal to the number of protons, and this applies to neutral atoms. Now, let me repeat, in getting the number of neutrons, still we will use the same formula, mass number minus atomic number. Okay, now we have this one. Positive ion is an atom that has lost electrons. Okay, take note of the keyword lost. Okay, so if an atom loses an electron, and we know that electron is negatively charged, so just imagine an atom losing a negatively charged particle, which is the electron. So what will happen? Of course, it will have it will become a positive ion, and we call them cations. Now we have the negative ions. This refers to an atom that has gained electrons. Okay, so take note of the keyword gained electron. So imagine an atom that gains electron, okay, or acquires electron, and you know that electron is negatively charged. Okay, so the atom now becomes a negative ion, and you call them an ion. Okay, so take note of those keywords. So if losing an electron, or the electrons are lost, it will become positively charged, or it will become a positive ion called cation. If an atom gained electrons, okay, now they will become negatively charged, or they will become negative ion, and you call them an ion. Now what is this charge? Charge, okay, this refers to the number of protons minus number of electrons. So that's how you will compute for charge. Number of protons minus number of electrons. So say for example in this one, chlorine has 17 proton and 17 electron. Since it says here charge is equal to number of protons minus number of electrons, so 17 minus 17 is equal to 0, and therefore we conclude that this chlorine in this example is a neutral atom. Okay, so how about potassium? Potassium has 19 protons and 19 electrons. So if you're going to compute for the charge of potassium, so 19 protons minus 19 electrons is equal to 0. So this potassium is also a neutral atom. Okay, that's how you will compute for charge. Number of protons minus number of electrons. Okay, so please take note of this one. Note, this is a neutral atom. So like I said, for chlorine and potassium, so we have here another example, carbon. Okay, so please note that our example here, which is carbon, is a neutral atom. Now if you're going to compute for the charge, so we have this representation here. You will see a left superscript. Okay, left superscript, this refers to the mass number, and for the left subscript, this refers to the atomic number. Okay, now if you're going to compute for the charge of carbon, so you have protons is equal to 6. Why 6? Because the atomic number is also 6. And for the electrons, it says that electron is equal to the number of protons. So electron, let me just put a charge, but proton is positive, electron is negative, and it is also 6 electron. Okay? And their mass number is 12. Now, if you're going to compute for the charge, you have their number of protons minus number of electrons. So, I'm sorry. We have here 6 minus 6 is equal to 0. So the charge is 0. And therefore, carbon is a neutral atom. Okay? Now, how about the number of neutrons? Okay? How about for the number of neutrons? We have mass number minus atomic number. So 12 minus 6 is equal to 6. So the number of neutron is 6. I hope you get that one. Now let's proceed. So try computing the number of subatomic particles of the following neutral atoms. So still, the following examples are neutral atoms. Say for example, we have here carbon, okay? Carbon with a mass number of 14, okay? That is the mass number 14. And the atomic number is 6. So compute for the number of neutrons rather. 14 minus 6 is equal to 8. How about the number of protons? So since we have the atomic number 6, so the number of protons is also 6. And how about for the number of electrons? It is also 6. Okay. Now, how about Be or beryllium? You are given the mass number 9 and atomic number 4 for beryllium. So, compute for the number of neutrons. Again, use the formula mass number minus atomic number. So, 9 minus 4 is equal to 5. So, the neutrons of beryllium is 5. Now, how about for protons? We have 4. And the electrons also is 4. Okay, did you get it? And then we have nitrogen. Nitrogen, the given mass number is 15 and the given atomic number is 7. So compute for the number of neutrons. So mass number minus atomic number. So 15 minus 7 is equal to 8. 15 minus 7 is equal to 8. And how about for the number of protons? We have 7. And of course, for the number of electrons, we have 7. Okay, take note, these examples are neutral atoms. So if you're going to compute for their charge, so protons minus what? Protons minus electron. So in this case, let me just change the color. So in this case, 6 protons minus 6 electrons is equal to 0. And therefore, this carbon has 0 charge, so it is still neutral. And for beryllium, we have 4 protons minus 4 electrons, so the charge is also 0. So beryllium is neutral. Now, for nitrogen, 7 protons minus 7 electrons, so the charge is also 0. So nitrogen in this example is also neutral. Okay, it's easy, right? Now, let's determine the number of subatomic particles. Yeah, this is still a continuation, but now you will see the charge. So in this previous examples, you cannot see the charge because these are neutral atoms. Now, for the ions, okay, the charge will be displayed just like for this example. So we have here this 23 is the mass number and 11 is the atomic number, and we have 1 as the charge. Okay, so the charge is written as the right superscript. For mass number, it is the left superscript. For atomic number, it is written here as the left subscript. Now for the right superscript, that is the charge. Okay, so look at that one. In this example, we have Na, or sodium. The mass number is 23. So mass number, again, this refers to protons plus neutrons. So 23 is your mass number. And your atomic number is 11. So atomic number is equal to the number of protons, but not to electrons because of charge. Since we are now talking about charged atoms or ions, okay, protons and electrons in this kind of atoms are not equal anymore. Why? Because of charge. And you call these atoms ions, okay? Remember that one? The atomic number now for ions, okay, is equal to protons, but not equal to electrons because of the charge. Now, you have here charge, okay? You have a +1 charge. So, how are you going to get the number of electrons? You have to use this formula right here, okay? Number of protons minus charge. So, get the number of protons and minus the charge. So, in this example, you have 11 atomic number, therefore your protons is also 11, and you are given the charge, which is +1. So 11 minus +1 or +1 is equal to 10. So I place letter E minus because that refers to the number of electrons. Okay, so there are 10 electrons. Okay, again, how are you going to get the number of electrons? Just get the number of protons and then minus it with charge. So neutrons here, how did you get 12? Because we have 23 minus 11, then we have 12. So that is why our neutrons is equal to 12. And our protons, since we have 11 for atomic number, then the protons is also 11. Then how did you get the number of electrons? Simply the number of protons minus charge. Yeah, it's very easy, right? Next example, we have oxygen. So look at that one. You are given the mass number 16 and then atomic number of 8. And you are given -2 as the charge. Okay? So, how did you get the number of neutrons? You have mass number minus atomic number, so 16 minus 8 is equal to 8. Therefore, the number of neutrons rather is 8. Number of neutrons is 8. Then you are given the atomic number. Therefore, your number of protons is also 8. Now, compute for electrons. Again, how are we going to compute for the number of electrons? So use this formula, number of protons minus charge. Okay, so you have this one. Now your number of protons is 8. So minus, okay, 8 minus -2, or you have to impose that in a parenthesis. So 8 minus -2, then the answer is 10 electrons. Okay, 10 electrons. So this means to say that the atoms gained 2 electrons. Okay, gained 2 electrons. On the previous example, since we have a positive charge added to sodium, so it has lost 1 electron. Okay, it has lost 1 electron. And this one, okay, it gained a -2 charge, so it gained 2 electrons. I hope you get that one. Okay, now let's proceed to the shapes of atomic orbitals for electrons. There are 4 different kinds of orbitals for electrons based on those derived for a hydrogen atom, denoted as S, P, D, and F. So please go back to your enhancement chemistry. What do you mean by S, P, D, and F? S and p orbitals are the most important in organic and biological chemistry. So for the s orbitals, the shape is spherical. So look at that one. The shape is spherical, and the nucleus is at the center. For the p orbital, okay, look at that one. The shape is like a dumbbell. The shape is like a dumbbell, and the nucleus is at the middle. And for the d orbital, okay, look at that one. They look like elongated dumbbell shape. Okay, it's like this is the first dumbbell and this is the second dumbbell, and the nucleus is also at the center. Again, how do you describe the shape of the orbital? For the s orbitals, it is spherical and the nucleus is at the center. And for the p orbital, it is dumbbell shaped and the nucleus is also at the center or middle of the dumbbell shape, right? And we have the d orbital, so it's like two dumbbells. So elongated dumbbell shape and the nucleus is at the center. Let's proceed to orbitals and shells. Orbitals are grouped in shells of increasing size and energy. Different shells contain different numbers and kinds of orbitals. Each orbital can be occupied by 2 electrons. So the line, okay, one line that you have seen in this illustration, that is the orbital, okay? And those arrows, okay, oh, I'm sorry. So let me draw that properly. That is the orbital, and those arrows that you see, okay, it represents electrons. The arrows represents the electrons, and it has been mentioned here that each orbital can be occupied by 2 electrons. Okay, the maximum of electrons is only 2 in each orbital. So we have here the first shell. Okay, for the first shell, it has the capacity of 2 electrons only. So you have the 1s orbital. That's why you can only see 1 orbital here. And the maximum of electron it can hold is only 2. Now, if we are going to proceed to the second shell, its maximum capacity is 8 electrons. So you have the orbitals 2s and 2p. For the 2s, you have 1 orbitals, and for the 2p, you have 3 orbitals. So 2s can hold 2 electrons, 2p can hold 6 electrons. Why 6? Because again, I said that each arrow represents electrons. So 2 electrons from 2s plus 6 electrons from 2p, 2 plus 6 is equal to 8. Okay? Now, moving up, we have the third shell, and its maximum capacity is 18 electrons, and we have the orbitals 3s, 3p, and 3d. So you have 1 orbital for s, 3 orbitals for 3p, and for the 3d we have 1, 2, 3, 4, and 5 orbitals. Okay, and again the orbitals are occupied by 2 electrons. So for the 3s, you have 2 electrons, and 3p, you have 3 orbitals. So 2 electrons times 3 is equal to 6. So in 3p, you have 6 electrons. For 3d, you have 5 orbitals occupied by 2 electrons each. So 2 electrons times 5 orbitals, you have a total of 10. So you have there 2 plus 6 plus 10 is equal to 18 electrons. Okay, so just remember that one. The maximum capacity of the first shell is only 2 electrons, and the maximum capacity of the second shell is only 8 electrons, and the maximum capacity of the third shell is only 18 electrons, and so on and so forth. Okay? first shell contains one s orbital. So I have mentioned that earlier, that the first shell contains only one s orbital, denoted by 1s, and it can hold up to 2 electrons. Second shell contains the 1s orbital, which is the 2s, and 3 orbitals denoted as 2p, and all in all, this contains 8 electrons. And for the third shell, okay, you have the s orbital and the 3 p orbitals, and the 5d orbitals are denoted as 3d. Okay, so it contains the 18 electrons in maximum. So in each shell, there are 3 perpendicular p orbitals. We have the px, py, and pz of equal energy. So lobes of a p orbital are separated by a region of 0 electron density called a node. Okay? So if you're going to go back to our illustration here, you have noticed that the p orbitals, okay, have, the second shell and the third shell containing the p orbital, okay, which is the 2p and 3p, only contains 3 orbitals. Now for the p orbitals, we have 3 kinds: the px, py, and pz. So this is the px, py, and pz. So that is their orientation. And the lobes, okay, the lobes of a p orbital, they are separated by a region of 0 electron density called lobe.